this lesson, we're going to look at parallel and perpendicular lines and how they relate to each other. Parallel lines are lines that have the same slope. And it's also true that lines with the same slope are parallel. So we can tell if lines are parallel by they're having the same slope. And we know that if we're told that two lines are parallel, then we know that their slopes will be the same. If we looked at the graphs of two parallel lines, since they are ones with the same slope, then we could talk about the line y equals 2x minus 3 and the line y equals 2x plus 2. So if we started with the first one, our intercept's at -3. We have a slope of 2. That means we go up to 2 to the right 1, up 2 to the right 1, up 2 to the right 1, as many times as we want to, and then we can draw that line. If we graph the second line there, y equals 2x plus 2, well, our intercept's at 2, and we have a slope of 2. So we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. We'll draw this line. And so we have two parallel lines. All the points are equidistant apart. And so parallel lines then are lines that have the same slope. That makes it then fairly easy if we're trying to write equations. And for certain things, you would not be given one line and you want to find the equation for the line that is parallel to it. So let's say that we have a line, we're wanting it to go through the point. We want it to pass through. We want it to pass through the point -2, 5. And we want it to be parallel. The symbol for parallel are two parallel lines. We want it to be parallel to y equals 3x plus 1. Well, all that we use this line for is to get the slope, because if it's parallel to this line, it will have the same slope as this line. So that means that this line has a slope of 3, so we're wanting it to have a slope of 3. We know the slope, we know a point, so we'll use our point slope. Y minus the given y is equal to the slope times x minus the given x. So if we put that in slope-intercept form, it was in the general form, we would have 3x minus the negative's a plus, 3 times +2 is +6. Then we would add 5 to both sides. So we have 3x plus 11. Now, if we wanted to see if this was true, let's just graph this. We've got a point that goes through the point -2, 5, a line that goes through the point -2, 5. It has, we want it to go through that point, and we want it to be parallel to the line y equals 3x plus 1. So if we drew that line, 3x plus 1, our slope is 1, and we go up 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. We can draw that line. Now we want the line that's going to go through this point and is parallel to that. Well, what we came up with was y equals 3x plus 11. And I'm not wanting it to go through positive 2, 5. What we said was, let's go back to that page. It was negative 2, 5. Okay, because we weren't going to be going through that point. But through the point negative 2, 5 is what we're supposed to do. So let's try this one. We got 11. Now, so our intercept is at 11, 2, 4, 6, 8, 10. That's going to be about here. Now, I said that I always go up and to the right when I can. This is a time that I'm going to run out of room. So this is a good chance to go through this. We get positives by dividing a positive by a positive. Now, a positive move would be up, a positive move would be to the right. We can also get a positive slope by doing a negative divided by a negative. Now, our negative moves would be down and to the left. So let's go down 3, 1, 2, 3, and to the left 1. Down 3, 1, 2, 3, to the left 1. Down 3, to the left 1. And you can even see that we did go through the point we were supposed to. And if we graph this now, then our lines are parallel, and we went through the point that we were supposed to, negative 2, 5. Okay, let's look at another one. Let's say that we want to go through the point 3, negative 6. So 3, negative 6. And we want to be parallel to the line x plus 3y equals 9. Well, we know that parallel lines have the same slope. So if we could figure out the slope of this line, then we're going to know the slope of the line we want. So we're going to solve this for y. So we'll subtract x and divide everything by 3. So we get y is equal to negative 1/3 x plus 3. Now all we need this for is to get our slope. So if we want the equation for the line that's parallel to that, it's going to have a slope of negative 1/3 and go through this point. So using our point slope, y minus the given y is equal to our slope times x minus the given x. Minus a negative is a plus, so negative 1/3 x. A negative times a negative is a positive. 1/3 of 3 is 1. Subtracting 6, we get negative 1/3 x minus 5. So this should be the equation that will be parallel to this line and go through this point. Again, if you wanted to see, let's go ahead and let's graph this line. So our intercept was at 3. We had a slope of negative 1/3. That meant we went down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. We can draw that line. And then our other one, our intercept was at negative 5. And we have a slope of negative 1/3. So we go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. And we'll draw that line. So we have two lines that are parallel, and we wanted it to go through the point 3, -6. So there's 1, 2, 3, 1, 2, 3, 4, 5, 6. So it did go through the point 3, -6. So parallel lines are lines that have the same slope. And if two lines have the same slope, then they are parallel. The other kind of lines that we want to look at are perpendicular. Now, perpendicular lines have slopes that are opposite reciprocals. What we mean by opposite is they have the opposite sign. The opposite of a positive is a negative. Opposite of a negative is a positive. So they have the opposite sign, and then they're reciprocals of each other. And if two lines are perpendicular, then the product of the slopes is -1. So if we were looking at that, if one line had a slope of 1/3, then the line that was perpendicular to it would have a slope of -3. Those are opposites and they're reciprocals. If you had a line whose slope was -2/3, then the line that is perpendicular to it would have a slope of +3/2. And if you had a slope of -1, then the line that would be perpendicular to it, ooh, let's see. What do we mean by, okay, we have a slope of -1, and so it would be the opposite reciprocal, so it would be +1. And when we multiply those two together, we do get -1. If we looked at some lines that were perpendicular and looked at their slopes, then let's say that we have the line y equals 2x minus 5, and then y equals -1/2 x plus 2. Okay, on the graphing the top one, we're at -5, and we have a slope of 2. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And if we draw that line, whoops. See if I can get that little line off. Okay, now let's try it. I'm not sure. Okay, so we've got that line. Now, if we want to do our other one, okay, we have an intercept of 2 and a slope of -1/2. We're going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and we'll draw this line. And so these would be perpendicular to each other. And they're at right angles. So this is our perpendicular lines. Now let's look at how we would write our equations given our information. Let's say that we want it to pass through the point -2, -6, and we want it to be perpendicular, that's our symbol for perpendicular, to x plus 3y minus 12 equals 0. Right, we know that perpendicular lines have slopes that are opposite reciprocals. So the first thing we have to do is to get the slope of this line. So we'll subtract x and add 12, or we could have just subtracted 3y, but we're going to subtract x and add 12. Then we will divide everything by 3. So we end up with y equals, that would be -1/3 x plus 4. So the slope of this line is -1/3. That means the slope of the line that's perpendicular to it will be a +3. And if you're in doubt, multiply them back together. positive 3 times negative 1/3 would be negative 1. So we simply have y minus the given y is equal to the slope times x minus the given x. Minus my given x, which was negative 2. So that gives me y plus 6 is equal to 3x plus 6. Subtracting 6, I get y equals 3x. And that would be my answer in slope-intercept form. You may need your answer back in the general form, which is the form that you were given. If you did, we could subtract y, and we would have 3x we would have 3x minus y equals 0. And we could go through and graph our points. So if we graphed the first equation that we had, we came up with y is equal to negative 1/3 x plus 4. So our intercept's at 4. Our slope is down 1 to the right 3, down 1 to the right 3, 1 to the right 3. Graph that line. And then we came up with the line y equals 3x. So in that case, our intercept is 0. We go up 3 to the right 1, up 3, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. We will draw this line. Okay, those lines appear to be perpendicular, and we were wanting to go through the point -2, -6. Well, if we look at the points that we went through, at -2, -6, you may say, well, I don't know because my line didn't go back that way. Well, let's just extend that line a little bit back and see where it would go. If we kept it straight, we didn't put down any points because we didn't want to force it to go through that point, but we are trying to line it up. And so if you look at that, I can let it go. Okay, -2, 1, 2, 3, 4, 5, 6. So we did go through that point. So for perpendicular then, you do the opposite reciprocal. Let's look at one more with perpendicular. Sometimes it's a little bit harder as you go through and you want to do your opposite reciprocal. Sometimes we forget about our signs and we don't do it quite as we need to. So let's say we want to go through the point 5, -9. We want to be perpendicular to x plus 7y minus 12 equals 0. Well, first of all, we're going to have to solve this for y. So we're going to subtract x and add 12, then divide by 7. So we end up with y equals negative 1/7 x plus 12/7. So the slope of this line is negative 1/7. So the slope of my line will be positive 7. So we have y minus the given y is equal to the slope times x minus the given x. Y plus 9 equals 7x minus 35. Then subtracting 9, we have y equals 7x minus 44. Now that's if you want your answer in slope-intercept form. If we want it in standard form, well, let's simply subtract y from both sides, but let's put it after the x. So we would end up with 7x minus y minus 44 equals 0. And that would be our answer in the general form. Okay, this is looking at slope with parallel and perpendicular lines. We want to look at slope in a little different way, and we're going to look at it in what we call the average rate of change. And we define the average rate of change as a change between the function at different times divided by the difference of that. It's very similar to your slope formula, your change in your y's over your change in your x's. But when we use the average rate of change is when our graph's not a straight line. And so we're wanting to know, not necessarily, it won't be the rate that it is all the time, but between those 2 points. If we had a parabola, well, we can tell that we can't find the slope of this at any point because it's not a straight line. And it's going to change and be different. So what we do is we pick 2 points on our parabola. We draw the line between those, which is called a secant line. And we find the slope of that line. And that would be what we call the average rate of change. This would be our f of x sub 2. So this point might be x sub 2, f of x sub 2, whatever your function is at that time. And this would be our x sub 1, and then f of x sub 1. And so we're finding the slope of that secant line. Now, we might find the slope between 2 other points on that same graph. And in this case, this one would have a negative slope. So they're not going to have the same slope all the time. Things don't always happen at a constant rate of change. If you're driving from one place to the other, well, we know that we get our average speed or average velocity by how far we went, our change in position, our change in distance, divided by how long it took us to get there. So it was our change in distance, or the distance that we went, divided by the time that it took us to get there, our change in time. But we know from experience that we didn't drive the same speed all the time. And sometimes we had even stopped. So that would be something that we might need to get an average rate of change on, and it's called our average velocity. People do not grow at the same rate. And in your lifetime, you don't grow at the same rate. When you're young, you might grow very rapidly, and then you start kind of slow down for a while. In your teenage years, you start growing again, and then you get to where you don't really grow at all. And as you get older, you may start getting shorter. And so you've got your height at different times. And so you may want to know, well, what was your average rate of change during these different times? So we're going to then look at what we call our average rate of change. And the formula we would use will be very similar then to our slope formula. And so let's look at some problems that we're going to deal with as our average rate of change. Okay, let's say that we want to take the equation or the function f of x equals x cubed. Now, if we looked at this graph, and we're going to be looking at graphs in the next lesson, but our graph would look something like this. So you can see that it doesn't have a constant slope. It changes and at different times. And so we've got our function, and we want to figure out, well, what's our average rate of change between when x is 0 and x is 2. So let's call x sub 0 x sub 1, and x sub 2 is going to be 1. So we want to know, well, what was the slope at that point between 0 and 1? So what we're going to do is we're going to take our function, f of x, and we're going to start by substituting in x sub 2, which was 1. So we'll find, let's just write it that way. We'll find f of 1 minus f of 0 divided by, okay, that x value was 1 minus 0. Now, when we plug 1 into our function, 1 cubed is 1, 0 cubed is 0, over 1 minus 0, so we get 1 divided by 1, which is 1. So that's our average rate of change between when x is 0 and x is 1. Now let's look at that same function at a different time. Let's say that we want to find it between the times when x sub 1 is 1 and x sub 2 is 2. And what you may want to do is go off to the side and find f of 1 would be 1 cubed, which is 1. F of 2 would be 2 cubed, which is 8. So we want f of x sub 2, which was 2, so that would be 8, minus f of x sub 1, which is 1, over x sub 2 minus x sub 1, over 2 minus 1, which is 7 over 1, 7. So our rate of change between 0 and 1 was simply 1, but between 1 and 2, the next two integers, we were growing at a rate of 7. Well, let's go on and let's see what would it be between when x sub 1 is negative 2 and x sub 2 is 0. Well, that would be back over on this side, going from here up to here, and finding out what our rate of change was. So x sub 2, we would be substituting in, we'd want f of 0 minus f of negative 2 over 0 minus negative 2. We want f of x sub 2 minus f of x sub 1. So 0 cubed is 0. Negative 2 cubed is negative 8 over 2 minus a negative 2, which is 2. So we end up with 8 over 2, which is 4. So that would be our average rate of change. And so it's a matter of plugging it into your formula at the different times. And as we said, things will grow at a different rate. And so you can't find, because they're not straight lines, you can't necessarily find the slope. And so you draw a secant line between those, and you can then find your average rate of change. The last thing that we want to look at in this lesson is how we would use some of this information and just write equations so that you could find different costs. And so we're going to take a fairly simple one. We want to write the equation for the cost of renting a car for 1 day, where you pay $20 per day and 10 cents per mile. Well, if you remember what we needed when we wrote an equation is we needed the slope, which is also the rate of change. And we just talked about that when we talked about our average rate of change formula. The slope is the rate of change. Well, usually that's written in a way of so much per day or per mile or per hour, per cent. These are things that deal with rate of change. So if we look in this, it talks about $20 per day, but we're only renting it for 1 day. And so we're going to pay $20. And so that per day doesn't really matter. If we were going to rent it for more than 1 day, then we might have to deal with that. But we're only renting it for 1 day. And so here's the rate that's going to be changing. As we drive, we're going to pay 10 cents per mile. And so our cost then for 1 day, our rate or our slope is going to be 10 cents per mile. And then we also have what we call our y-interceptor. We said that was the beginning. You're going to pay $20 for this car for that day, whether you drive it any or not. So you might rent it, drive it 1 mile, and then you don't drive it anymore. You're still going to pay that $20. And so our intercept, our beginning, is the $20. So as we put this into our equation, then we would have that the cost of the car, and sometimes you might even want to say, well, I'm going to begin at $20, and then I'm going to add 10 cents per mile. And maybe we want to use an M here since we're representing miles. We might want to use a C for the cost. And so we've got that it's going to be $20 plus 10 cents per mile. If you wanted it in our standard slope-intercept form, then it would be 10 cents per mile plus the $20. Either way, that's going to be the same, and it's just kind of how you want to look at this. So we can use all of this idea as we start writing our equations, and we can come up then with equations for our different situations.